You might have controlled the speed of this DC motor by using PWM technique in Arduino. But do you know that how do we actually implement the same PWM technique in ESP32? Because analogWrite function cannot be used to control the speed of any DC motor or any other component, right? So how do we actually control the speed of this DC motor using PWM with ESP? So let's explore this in detail in this video. Now before moving further, let us take a look at the pinout of the components and the connections among them. So with this motor diver, you can connect maximum 2 DC motors. Okay. So I'm going to connect the motor at these two terminals. And this pin is for the 12 volt input supply. This middle pin is for the ground. And this third pin is a 5 volt output pin. And remember that these three pins are used for this motor. And the last three pins are used for this motor. And this first pin and the last pin are used to control the speed of the motors using PWM technique. And remember that in this project we are using ESP32, which can operate at a maximum 3.3 volt. But what most of the beginners do, they mistakenly connect this 5 volt output pin with the input voltage pin of the ESP32. And because of that, their ESP32 gets fried. So you should avoid this mistake. So I will connect this orange pin with the 12 volt input supply of the battery. And remember that I am going to power the ESP32 from my laptop via this USB cable. And the motor driver will be powered from this battery. So there are two power sources in this project. One is a battery and other one is this USB cable. So there must be a common ground between the battery and the USB cable. So because of that, I have taken out two jumper wires from the ground pin of the motor driver. One is this gray wire and other one is this white. Okay. So these two pins will be connected to the battery and this white wire will be acting as a common ground. So I will connect this white colored wire with the ground of the ESP32, which is here. Okay. And you can connect the ESP32 with this USB cable. Now in this program, all the three pins of the motor driver are defined. Like this is the PWM pin, this is the direction 1 pin, and this is the direction 2 pin. And this is the PWM configuration settings. So PWM signal is basically a digital signal which is turned off and turned on very quickly. So the frequency is 1 kHz. And this is a PWM resolution. So basically ESP32 can support a maximum resolution of 16 bits. So I am using a PWM resolution of 8 bit. You can also use 10 bits, 12 bit and maximum 16 bits. So with 8 bits resolution, you will get up analog values from 0 to 255. And in the setup function, both the direction pins are defined as output mode. And we are attaching the PWM pin with the PWM settings like PWM frequency 1 kHz and PWM resolution of 8 bits. So when we implement the PWM technique with ESP32, we need this function LEDC attached to attach this pin with the configuration frequency and the resolution. So LEDC stands for LED control, and it is not the case that you are bound to control only the LED with PWM. It is just the function name, and you will not see this function in case of Arduino, because while implementing PWM in Arduino, we need the function analogWrite, and with analogWrite function we cannot change the frequency and the resolution. They are fixed. Now in this function set motor speed, we are determining the direction and the speed of the motor. So the speed can go from -255 to 0 and then from 0 to 255. And if the speed is greater than 0, it means if the speed is in this range 0 to 255, then we are sending high signal on the direction 1 pin and low signal on direction 2 pin. And this function LEDCWrite is used to control the speed, but in Arduino we use the function analogWrite. And if speed is less than 0, it means the speed in this range -255 to 0, then the motor is rotating in the opposite direction. Otherwise, at this position, middle position, we are stopping the motor. Now in the for loop, we are increasing the speed, then we are slowing down, and then we are reversing the direction. So we are increasing the speed from 0 to 255 each time by 5 units, and we are calling this function set motor speed. And for slowing down, we are changing from 255 to 0 and decreasing by -5 units. And here we are reversing the direction. And this function is called to stop the motor. So let me know in the comment section whether you were already familiar with how to implement PWM with ESP32 or not. And if you enjoyed this video, don't forget to subscribe to my channel and share this video. This helps me a lot. And see you in the next video.